Imagine taking every physics textbook on Earth, right? Like from the dog-eared copy you had in high school all the way up to Albert Einstein's original handwritten manuscripts.
That is a lot of paper.
Yeah, a massive stack. And imagine taking a thick red marker to all of them, turning to every single page, finding the symbol for pi, and just crossing it out.
Just completely redacting it.
Exactly. Now, you'd think doing that would break the universe. I mean, you'd think planes would fall out of the sky or GPS satellites would spin out of control and our entire understanding of reality would just collapse.
Right, because we rely on it for everything.
Right. But what if crossing out pi doesn't break the universe at all? What if it actually fixes it?
It is a really jarring thought experiment, honestly,
Yeah.
because we are so deeply conditioned to revere pi. I mean, 3.14159 is treated as the absolute bedrock of reality.
Oh, totally. We print it on coffee mugs. We beam it into outer space to show aliens we're smart.
We really do. But the premise we are exploring today suggests that this sacred number, this infinite string of decimals that we've practically worshipped for centuries, might just be the biggest mathematical illusion in human history.
Which is a wild claim. So welcome, everyone. We have a mission today, and it is going to require you to just leave everything you think you know about the shape of the universe at the door.
Definitely.
We are jumping into a completely radical 2026 paper by George James Dukas. It's called End of PI in a Phi Universe, and it outlines something called the Transdimensional Unified Field Theory, or TDUFT.
And the core thesis of Ducas's paper is essentially this pi is not a fundamental constant of nature.
At all.
At all. It never was. The paper argues that the only reason it shows up in our equations, whether we are calculating the gravitational pull of a black hole or, the electromagnetic field of a simple magnet, is because early scientists made a massive, unexamined assumption about the blank canvas of reality.
And what was that assumption?
They assumed that the vacuum of space was spherical, or, well, at the very least, circularly symmetric.
Okay, let's unpack this. Because the stakes here are almost uncomfortably high for anyone who follows physics.
Oh, they are.
We're talking about dismantling the towering pillars of modern science. I mean, electromagnetism, gravity, quantum mechanics, just erasing pi from the chalkboards of history and replacing it with something entirely different.
Replacing it with the golden ratio.
Yeah.
1.618.
Yeah. And it forces us to ask a really uncomfortable question about how science is actually done, right?
Yeah, because if you assume the universe is built on circles from the start, you will eventually have to force pi into your math. You have to make your real-world observations fit that initial assumption.
You're kind of reverse engineering the math to fit your bias.
Exactly. But Dukas argues that when you correct the underlying geometry, when you realize the vacuum of space is not a smooth sphere, pi just simply vanishes. It becomes totally obsolete.
Okay, so by the time we wrap up this deep dive, you are going to see the fabric of reality completely rewritten. We're looking at a universe with zero free parameters, united entirely by the golden ratio.
Which is beautiful, mathematically speaking.
It is. But that leads us to the most obvious guiding question to start with. If the universe isn't built on circles, if the fundamental vacuum of space isn't a sphere, what shape is it?
Well, to really visualize that, I think we first need to understand how the spherical assumption infected physics in the first place.
Okay, yeah. Let's go back.
Think back to early scientists who were trying to map out invisible forces. When someone like Michael Faraday or James Clerk Maxwell thought about a magnetic field radiating from a magnet or light radiating from a star, they had to picture it somehow.
Right, they needed a mental model.
Exactly. And the most intuitive way to picture something expanding outward in all directions in a uniform void is a perfect sphere, like a three-dimensional ripple in a perfectly still pond.
Which makes total sense. I mean, if I turn on a light bulb in the middle of a dark room, the light travels out equally in every direction. It creates a sphere of illumination. So why wouldn't they assume the vacuum itself supports that shape?
It's the most logical jumping-off point. They assumed space was perfectly isotropic.
Meaning it looks and acts the exact same in every conceivable direction.
Right, a smooth, continuous, featureless void. And because of that foundational assumption, whenever physicists needed to describe the propagation of a field or the curvature of space-time, they naturally reached for the math of circles and spheres.
Which brings in pi.
Which brings in pi. This spherical assumption just seeped into Maxwell's equations for electromagnetism. It seeped into Coulomb's law for electric charges. It eventually became the geometric bedrock of Einstein's general relativity. They all just treated the underlying canvas of the universe as a smooth, continuous bubble.
And according to this paper, that smooth bubble is just a complete fiction.
Completely. According to TDUFT, the vacuum of space is not smooth, and it is certainly not spherical. It is phi recursive.
Phi recursive.
Yeah. Dukas proposes that the fundamental structure of the vacuum is actually a 64 tetrahedral lattice, and it's built entirely on pentagonal symmetry.
Okay, I'm going to need you to slow down and paint a picture for me here. A 64 tetrahedral lattice with pentagonal symmetry. That sounds like something out of a sci-fi novel.
It does sound intense.
What does that actually look like if I could, zoom in on the empty space right in front of me right now?
Well, picture something closer to the jagged, interlocking structure of a crystal, or maybe a really complex piece of origami.
Okay.
A tetrahedron is just a pyramid with a triangular base. Now imagine 64 of those pyramids interlocking perfectly. They point inward and outward, creating this incredibly rigid, highly structured grid.
So it's not smooth at all.
Not at all. This structure doesn't have the smooth, infinite rotational symmetry of a circle, which is what 2 pi represents. Instead, it has ninefold rotational closure.
Got it.
It is jagged, it has sharp angles, and because it is based on pentagons and recursive triangles, its fundamental mathematical DNA isn't pi. It is phi, the golden ratio.
Okay, think about it like this, for you listening. Think about a time you were trying to measure something with the wrong tool. Imagine you are hired to calculate the volume of a massive room. And this room is built entirely out of cubic blocks.
Right. Sharp angles everywhere.
Exactly. Everything is sharp angles, straight lines, perfectly rigid geometry. But for some inexplicable reason, you insist on using a spherical ruler, like a tool designed exclusively to measure the curves of a globe.
That is actually a very apt way to look at it.
Because you would go around this jagged cubic room, laying down your curved ruler over and over, just trying to calculate the straight edges. And because your ruler doesn't fit the room, your math is going to get incredibly messy.
You'd end up with endless fractions and decimals.
Yeah, you were going to end up with infinitely repeating decimals. You might look at your notebook and think, wow, the universe is so mysterious. Look at these profound, transcendental numbers required to measure this room.
But the room isn't mysterious. Your ruler is just wrong.
Exactly. And according to Dukas, that is what pi is. It is literally just a mathematical patch for a fundamentally flawed ruler.
Yeah, and the real problem with pi is that it doesn't allow for what mathematicians call recursive self-similarity in a three-dimensional structure.
But phi does.
Phi does. In this 64 tetrahedral lattice, phi allows the structure to scale up and scale down infinitely while maintaining its exact shape.
I like fractals.
Very much like fractals, it provides dimensional closure. And because it is rigid geometry, it establishes an absolute mathematical ceiling for things moving through it.
Oh.
Which actually brings us to a concept in the paper that completely redefines how we view reality. Epsilon.
Oh, man, the universal emergence deficit. I was reading this section, and I swear I felt like I had to read it 3 times just to make sure I wasn't hallucinating.
It's a mind bender.
Break down epsilon for us, because it redefines literally the most famous speed limit in the universe.
Right. So epsilon is a very specific derived value in this framework. The number is 0.00077542.
Okay, keeping that in mind.
To understand why this number is so revolutionary, we have to look at the speed of light in a vacuum. Physicists denote it with the letter c. If you look in a textbook right now, the speed of light is roughly 2.9979 times 10 to the 8th meters per second.
Right, and standard physics just says, well, that's what it is. We measure it, we confirm it, and we just accept it as a raw, brute fact of nature. It's a messy number, but it's the rule.
Exactly. Standard physics accepts it as strictly empirical. We measured it, so it is what it is. But TDUFT argues that the speed of light is not a random empirical measurement. It is actually derived from pure geometry.
How so?
Dukas explains that in a purely theoretical, pure geometric maximum state, like if the universe was just pure math with no physical substance, the speed limit wouldn't be 2.9979. It would be exactly 3, a perfect, clean integer 3.
Okay, I'm struggling with this jump just a bit. Why 3? And if it's supposed to be 3, why do we actually observe 2.9979? Like, where does the rest of it go?
Think back to the lattice. The vacuum is not empty nothingness, right? It is a rigid, phi-based geometric grid.
Right, the 64 tetrahedrons.
Yes. Pure math can have a perfect speed of 3, but when that pure abstract geometry has to translate into physical, tangible reality, when a photon actually has to propagate across this jagged tetrahedral lattice, the universe demands a toll. The process of emergence, of becoming physically real, requires energy.
Wait, so reality itself has a friction coefficient?
In a sense, yes.
Yeah.
The paper calls it the emergence deficit. When pure geometry becomes physical reality, it pays the epsilon tax.
The epsilon
Yeah.
tax.
So if you take the pure geometric maximum of exactly 3 and you subtract epsilon, which is 0.0000007542, you get exactly 2.9979245.8, which is the exact internationally recognized code at a speed of light.
That is just, I mean, it's like finding out the matrix code is real.
It really is.
The universe has a literal exchange rate. When the math cashes itself out into physics, it gets charged a tiny geometric fee. And suddenly, this clanky, random-looking speed of light is revealed to be a perfect integer 3 minus a very specific structural tax.
And this is something Pi is completely incapable of doing or explaining. Pi worked as an approximation for centuries, because if you zoom out far enough, a massive 64 tetrahedral lattice can look somewhat spherical in its macro effects.
Just like if you zoom in on a circle on a computer screen, you see it's actually made of jagged square pixels.
Exactly.
But if you stand across the room, it looks like a smooth curve.
And we have been standing across the room for centuries. But when you get down to the foundational level, Pi is completely absent.
Which feels like the perfect pivot point for us. Because a pi is just a macroscopic approximation that worked well enough when we were looking at things from a distance. What happens when we zoom in on the ultimate theory of the macro universe? I'm talking about the absolute undisputed titan of 20th century physics, Albert Einstein's general relativity.
Well, general relativity is widely considered the most beautiful, elegant mathematical framework ever devised.
Yeah, it's untouchable.
And it has passed every single observational test we have thrown at it for over a century. But according to the TDUFT framework, Einstein's masterpiece is utterly saturated with the pi deception.
Okay, where is pi hiding in relativity? Because when I think of relativity, I don't immediately think of circles. I think of time slowing down or, black holes.
The most glaring example is right at the heart of the theory. It's Einstein's gravitational coupling constant. The formula is 8 pi g divided by c to the 4th power.
Okay, 8 pi.
Yeah. That 8 pi isn't there by accident. Einstein built his entire geometric machinery on the assumption of spherical curvature. When he needed to calculate vacuum energy density, he assumed it was distributed spherically.
Which requires the surface area of a sphere.
Exactly, which is 4 pi r squared. When he calculated the paths objects take through spacetime, which are called geodesics, he assumed they were based on circular mechanics. He built a magnificent, intricate castle, but he poured a spherical foundation to do it.
Let me just make sure I'm wrapping my head around this. Einstein didn't discover that gravity naturally produces the number pi. He mathematically forced pi into his equations of gravity because he was operating under the unquestioned assumption that gravity was curving a smooth spherical vacuum.
Precisely. The pi is an artifact of the assumption. It's not a property of gravity itself. And this leads to what is arguably the most radical fix proposed by Dukas in the entire paper. The text explicitly states that curvature, the very mechanism Einstein used to explain gravity, is, quote, complete nonsense. As a fundamental mechanism, it must be discarded.
Okay, wait, I have to throw a flag on the play here.
I figured you would.
Yeah, I think anyone who has ever taken a high school physics class or watched a science documentary on PBS is going to have a really hard time swallowing that. The ultimate go-to analogy for gravity is the bowling ball on a trampoline.
We all know it well.
Right. You put a heavy mass, the bowling ball, in the middle of a stretched elastic sheet, and it creates a curve, a dip in the fabric. And if you roll a marble nearby, it falls down that curve toward the bowling ball. That is the definition of gravity we've all been taught. Are you telling me this deeply ingrained, universally accepted analogy is just completely wrong?
The paper argues that it is fundamentally misleading, yes.
But the math of curvature predicts things perfectly. I mean, we used Einstein's curvature math to discover black holes. We used it to detect gravitational waves with LEGO. How can a mathematical framework be complete nonsense if it works so incredibly well? If gravity isn't a curve in a trampoline, how does this phi universe explain it without pi?
That is the crucial hurdle to overcome, for sure. How can something be so predictively accurate and yet structurally wrong? Dukas explains that curvature is merely a shadow.
A shadow.
Yeah. It is an emergent artifact of density gradients projected from higher dimensions.
I'm not sure I follow. A shadow of what?
Think about it this way. Imagine you are holding a complex three-dimensional object, say a tightly coiled spring, and you shine a flashlight on it, casting a shadow on a flat two-dimensional wall.
Okay, I picture that.
That shadow is going to have very specific shapes, curves, and behaviors. You could spend your entire life measuring that shadow. You could invent brilliant, highly predictive mathematics to describe exactly how the shadow's curves will behave when you rotate the spring, and your math would be 100% accurate at predicting the shadow.
But I wouldn't actually be describing the spring itself, I'd just be describing the 2D projection.
Exactly. Einstein spent his life writing the definitive mathematical rules of the shadow. His curvature tensors describe the emergent effects perfectly, which is why LIGO can detect gravitational waves based on his math. But he mistook the shadow for the object itself. He thought space-time was actually bending like a sheet. TDUFT says the vacuum lattice doesn't bend, it doesn't curve like a trampoline. Instead, it experiences changes in density.
Okay, so if it's not curvature, what replaces Einstein's curvature tensors in the math? How do we calculate this density?
This is where TDUFT introduces the new operator math of the codex framework. Remember, we are replacing static spheres with dynamic recursive geometry. To do this, the paper relies on two primary operators.
All right, what are they?
The first is phi, the golden ratio, which governs expansion. It acts as the velocity asymmetry operator. The second is a totally new operator called psi, which governs contraction. It acts as the time asymmetry operator.
So we have phi pushing things outward, expanding, and psi pulling things inward, contracting, and acting as time.
Correct. Because the concept of a curving manifold is discarded, Einstein's massively complex curvature tensors the mathematical engine of his theory. They completely collapse to zero. They're wiped off the board.
Zeroed out entirely.
Gone. And they're replaced entirely by these operators. In this new framework, density is no longer calculated by measuring the volume of a sphere. Density becomes simply t squared, where t represents the time recursion operator, which is psi.
Hold on, you're saying the density of an object, like how much stuff is packed into a space, is fundamentally just the time operator squared. Density is made of time.
In a recursive lattice, yes. The contraction of the lattice, that inward pull, is what we perceive as time. And the concentration of that contraction is what we perceive as mass and density.
That is wild.
And it flows brilliantly from there. Because if density is t squared, then gravity itself, represented by the constant g, is no longer a random empirical number tied to spheres. Gravity becomes exactly 1 divided by t to the fourth power.
1 over t to the fourth? That's it. That's gravity.
That is gravity. No pi, no curvature, no empirical guessing, no bowling balls on trampolines. Gravity is simply a direct mathematical consequence of time contraction and density gradients within the tetrahedral lattice. You strip away all the transcendental artifacts, and you are left with phi, which is recursive geometry, psi, which is contractive time, and epsilon, the emergence deficit.
Let me try to synthesize what this actually means, because it's just a massive paradigm shift. It means Einstein was looking at the exact right phenomena. He saw gravity, he saw orbits, he saw time dilation, but he diagnosed it with the wrong disease.
That's a great way to put it.
He thought space was literally curving, stretching like rubber, when in reality, the fundamental crystalline lattice of the universe was experiencing localized changes in density, driven purely by the interplay of time and expansion operators.
You've captured the exact distinction. And the moment you accept that curvature is an illusion, a shadow on the wall pi loses its only job in the equation. It is evicted from general relativity entirely.
But here's what I keep getting hung up on with this. During the entire 20th century, we had an explosion of absolute genius in physics. I mean, Bohr, Heisenberg, Schrödinger. Surely someone had to have gotten close to this. If Einstein's geometric interpretation was a dead end, did any mainstream physicist actually brush up against the truth of this phi-psi operator universe?
Yes, they did. But what is truly fascinating and almost tragic, really, is that the person who did it seems to have done it completely by accident, without ever realizing the geometric implications of his own math.
Which brings us to Paul Dirac. I love this part of the story. Set the stage for us. In the context of this massive structural overhaul of reality, who is Dirac, and why is he the accidental hero of this paper?
Well, Paul Dirac is universally recognized as one of the founding fathers of quantum mechanics. In the late 1920s, he formulated the Dirac equation. It is a legendary piece of mathematics that describes the behavior of fermions, particles like electrons, and it famously predicted the existence of antimatter before anyone had ever actually observed it.
Right, he's a giant in the field.
Absolutely.
Yeah.
But in the context of TDUFT, Dirac represents something much more profound. His equation is the very first mainstream mathematical model that accidentally touched the true operator structure of reality.
And crucially, he did it without relying on pi.
He did. But while his equation didn't have pi, it did contain something that deeply puzzled physicists, a mysterious, inexplicable negative unity. a negative one.
Just a rogue -1 sitting there.
Exactly. For decades, standard physics treated this negative sign as just an abstract mathematical necessity, a quirk of what they call spinor inversion. They needed it to make the math work, but they didn't believe it had a profound geometric shape behind it. Dukas, however, reveals the codex identity at the very heart of this negative one. According to TDUFT, phi multiplied by psi equals -1.
Wait, let me make sure I'm hearing you correctly. The golden ratio, phi the expansion operator, multiplied by psi, the time contraction operator, equals exactly -1.
Yes, it represents the multiplicative closure of the universe's expansion and contraction. They perfectly balance each other out in an inversion. Dirac found the algebraic footprint, the shadow, of this geometric truth. But because he didn't know about this 64 tetrahedral lattice, he didn't know the physical geometry that was producing his math.
Here's where it gets really interesting. The paper describes Dirac in a way that is incredibly vivid. It doesn't just call him a guy who wrote a neat equation. It describes the Dirac operator as the literal gate between abstract geometry and physical mass.
Yes, the mass emergence gate.
At first, I was picturing this like a cosmic 3D printer. Like, Dirac's equation is the machine where abstract math gets printed into physical matter for you to touch and feel. But that feels a bit too clunky. How does this actually work mechanically?
Let's look at the actual mechanism the paper proposes. It's called the dimensional ladder. This ladder maps how reality scales up from pure energy to physical matter. At the foundational step, you have what TDUFT calls D2. This is the photon tier, the tier of electromagnetism and charge.
And photons, particles of light, have no mass. So this D2 tier is completely massless. It's just pure energy propagating through the lattice.
Exactly. But how does the universe get from massless light to heavy, solid, physical matter that you can touch? Standard physics has a very complex explanation involving the Higgs field. TDUFT uses a surprisingly simple dimensional emergence equation. D squared plus 1 equals D cubed.
D squared plus 1 equals D cubed. I'm going to need you to unpack that. What does adding 1 to a dimension actually do?
Think of D as a dimensional operator. It is an instruction for the lattice to fold or scale. D2 is the massless photon tier. D3 is the mass tier, the voltage tier, where solid matter actually exists. The Dirac operator sits exactly at this transition point. When you apply the time inversion operator, which acts as that +1, you force the pure energy of D2 to recursively fold in on itself.
Okay, I see.
That localized recursive folding creates density. And as we established earlier, density is what we perceive as mass. Dirac's equation was the very first time in history that a physicist successfully introduced mass into a wave equation. He essentially modeled the D3 boundary.
So Dirac was standing right on the threshold of physical reality. On one side of his equation, you just have pure geometry. Phi and psi waving back and forth in a massless void. On the other side, the geometry folds in on itself, pays the epsilon deficit tax we talked about, and boom, you have mass, you have matter, you have a physical universe.
That is precisely what is happening mechanically. The paper explicitly states that Dirac's work is not a separate, standalone quantum theory. Dirac is a codex operator. Because mass and density are fundamentally tied to time, T-squared Duicke's equation requires a temporal recursion, an inward folding of time, not a spatial one. He was the first human being to catch a mathematical glimpse of the operator reality, even if he didn't realize it.
It is incredibly poetic, really. He picked the lock on the door, but he couldn't see the shape of the room on the other side. He found the -1, but he didn't know it was made of phi and psi.
It is a profound historical irony.
Okay, so if Dirac's math explains how mass emerges in the first place, how it folds into existence via the psi operator, we now have a universe with physical stuff in it. The next logical step is understanding how that stuff moves and how it sticks together. We need to look at the absolute largest scales of motion and the absolutely microscopic scales.
We should definitely tackle the macro scale first, planetary orbits. Ever since Johannes Kepler and Isaac Newton, classical orbital mechanics has been totally inextricably reliant on pi.
Always.
If you want to calculate the path of the Earth around the Sun, you measure angles in radians, which uses pi. You parameterize conic sections like ellipses using pi. You use Kepler's third law of planetary motion, which explicitly features a 4 pi squared term.
Because, again, it comes back to the visual assumption. We look up at the night sky, we watch the planets move, and they look like they are traveling in giant circles, or at least slightly squished circles, ellipses. And our brains are pattern-matching machines, so we immediately go, aha, circles, bring in pi.
It is a completely understandable assumption, but TDUFT argues it is structurally incorrect. According to Dukas, planetary orbits are not conic sections. You do not need to slice a geometric cone to understand how a planet moves. Orbits are free ellipses.
What is the mechanical difference between a standard ellipse and a phi ellipse?
The paper introduces a single, incredibly elegant geometric constraint to define any orbit. R sub A times R sub B equals phi.
Okay, what are r sub a and r sub b?
They represent the radial coordinates of the orbiting body, specifically the apoapsis and periapsis. That's the absolute furthest point the planet gets from the star and the absolute closest point. Classical mechanics uses complex eccentricity formulas and pi-based math to describe this elliptical path. TDUFT throws all of that out. The new orbit equation is rebuilt purely from the two operators we've been discussing.
Phi and psi.
Exactly. Phi handles the dilation, the outward expansion of the orbit, pushing the planet away. Psi handles the contraction, the time progression, pulling the planet back in.
So you don't need a smooth curve. You just need the expansion operator and the contraction operator constantly tugging against each other in harmony.
Exactly. The new radius equation contains absolutely no pi. It has no trigonometric circumference terms, like sines or cosines. It has no transcendental constants. It is a pure harmonic modulation of a closed phi-psi radius.
Wow.
Phi sets the spatial ratio. Psi introduces the temporal asymmetry, which ensures the planet speeds up when it gets closer to the star and slows down when it gets further away. And that core identity we discussed earlier, phi times psi equals -1, provides the exact mathematical orbital inversion symmetry needed to close the loop, without ever once needing the geometry of the circle.
It is just breathtakingly clean. When you explain it like that, it makes our current model of orbital mechanics look like a massive, over-engineered contraption held together with duct tape and pi, but that handles the massive macroscopic scale of stars and planets. Let's zoom all the way down to the other end of the spectrum, the microscopic scale, quantum chromodynamics, or QCD. The strong nuclear force.
Right, moving from the biggest to the smallest.
Exactly. This is the glue that holds the nucleus of every atom in your body together. Does pi infect the quantum realm too?
It doesn't just infect it, it completely saturates it. Quantum chromodynamics is riddled with pi. We see it in loop integrals, in renormalization constants, in what physicists call the QCD beta function, in decay widths. It is everywhere.
But why? I mean, I understand why they use circles. For planets, they look like they're moving in circles, but quarks inside a proton, they aren't orbiting like little planets. Why did physicists inject pi into the strong nuclear force?
For the exact same fundamental reason Einstein injected it to gravity. They assumed a smooth isotropic vacuum. When quantum physicists tried to map out the momentum of these subatomic particles, they assumed that momentum spaces exist in smooth spherical shells. They relied on circular Fourier transforms to process their data. They assumed the microscopic vacuum was a Euclidean smooth space manifold.
Okay, I want to break down those terms because they sound a bit intimidating. Euclidean smooth space manifold just means a reality that curves smoothly without any jagged edges, right? And a Fourier transform is a mathematical tool they use to break apart wave frequencies, but they built the tool assuming the waves were perfectly circular.
That is a perfect translation. Even when physicists were looking at the smallest, most jittery, abstract quantum parts of reality, they were still mentally drawing little smooth spheres to contain them. But as we established in the very beginning, the vacuum is a discrete anisotropic lattice. It is jagged. It is geometric. It is composed of 64 tetrahedral grids. It is not smooth at all. Because of this, TDUFT argues that the strong nuclear force is not a smooth gauge field living on a manifold. The paper redefines the strong force completely as a torsion cohesion process.
Torsion cohesion. Okay, torsion means twisting. So instead of thinking of subatomic particles as vibrating inside smooth little spherical bubbles, we should picture them violently twisting and locking onto a jagged crystalline pentagonal grid, like interlocking gears violently snapping together.
That is exactly the visualization.
And because they are twisting along this rigid geometry, that completely removes the need for pi.
You've nailed the mechanism. The strong force isn't a mysterious glue in a smooth void. It is the physical twisting and binding of the lattice itself. When you replace the Euclidean smooth space geometry with the jagged lattice, all of those pi-heavy mathematics simply vanish. The complex 16 pi squared beta functions, gone. The circular Fourier spherical normalizations, gone. They are entirely replaced by discrete phi gradient operators. Pi is evicted from the strong nuclear sector because pi never belonged there in the first place.
It's like discovering that the engine of your car isn't running on fluid gasoline. It's actually a clockwork mechanism made of rigid, interlocking gears. And for decades, we've just been pouring liquid gas all over the gears, trying to use fluid dynamics to explain why the gears are turning, and wondering why the math is so incredibly messy. We were forcing smooth spherical math onto a rigid, jagged pentagonal reality.
It is a completely unified elimination of the spherical assumption. Whether you are zooming out to calculate the gravitational pull of a galaxy or zooming in to calculate the strong force binding a single quark, the underlying culprit was always the same. We assumed the void was a smooth bubble.
This is a perfect place to transition because if we have fixed macroscopic gravity and we have fixed the emergence of mass with Dirac's boundary and planetary orbits and the quantum strong force, there's only one foundational stone left to overturn. We have to talk about light itself, electromagnetism, and the absolute baseline units of the universe.
We do. And to do that, we have to start with James Clerk Maxwell. Maxwell's equations, formulated in the 19th century, unified electricity and magnetism. It was a monumental achievement in human history. But as we discussed earlier, Maxwell assumed that fields radiate in perfect spherical shells. Because of this, pi was hard-baked into the two most fundamental constants of electromagnetism, mu0 and epsilon0.
Let's define those for anyone who might be rusty on their physics. Mu0 is the permeability of free space, and epsilon0 is the permittivity of free space. These numbers basically describe how much natural resistance the vacuum of space gives to a magnetic or electric field, correct? Like how well the vacuum can store an electric charge and how much it resists a magnetic pole.
Yes, they set the baseline physical properties of the void, and Maxwell's classical equations define mu0 as exactly 4 pi times 10 to the negative 7. There is that 4 pi again, explicitly demanding a spherical geometry to calculate magnetic resistance.
So how does the TDUFT framework rewrite Maxwell? If we throw out the 4 pi, how do we replace these foundational constants of electricity and magnetism?
In Dukitz's framework, these constants are no longer random empirical numbers tied to spheres. They become pure, algebraic, operator-based ratios. Epsilon 0, the electric storage capacity of the vacuum, is replaced by phi squared multiplied by d squared. That's it. The velocity expansion operator squared times the dimensional operator squared.
Wait, you're telling me epsilon 0, this messy, pi-infected constant that electrical engineers have used for over a century, is fundamentally just the golden ratio and the dimensional folding operator interacting?
Yes. And mu0, the magnetic resistance, becomes phi cubed, divided by psi squared times d to the 6th power. They are geometrically derived, they are dimensionally consistent, and they are completely pi-free.
And what happens if you plug those new operator formulas back into the classic equation for the speed of light? Because standard physics says the speed of light is 1 over the square root of mu0 times epsilon 0.
When you combine these new operator-based constants, it perfectly outputs the exact TDUFT speed of light formula we discussed earlier, 3 minus epsilon times 10 to the 8th. The math locks together with absolute, airtight precision.
It is almost too elegant. It makes everything we currently do look archaic. But I have to ask about the absolute basement of reality. Planck units. The Planck time, Planck length, Planck mass. These are supposed to be the pixel size of the universe, the absolute smallest indivisible units of measurement before the laws of physics just completely break down. If the universe isn't made of spheres, what happens to the pixels?
The Planck units are preserved in their physical meaning. They still represent the foundational limits of reality, but they are completely liberated from pi. Classical Planck units are heavily contaminated by pi because they rely on radial normalization, circular frequency, and Einstein's curvature-based gravity to derive their values. TDUFT strips all of that away and converts the Planck units into pure expressions of the lattice operators.
Walk us through them. Give us the new baseline pixels of reality. Let's start with time.
Let's start with Planck time. In classical physics, you calculate Planck time with a very messy equation involving a square root, the gravitational constant, the speed of light, and Planck's constant. TDUFT says that Planck time is simply t, and t is equal to psi, the contraction operator.
Time isn't a flowing river. Time is literally just the localized contraction of the 64 tetrahedral lattice.
Exactly. It is a mechanical action. Next, we have Planck length. Classical physics uses another highly complex, messy square root. 2DUFT says Planck length is simply d, the dimensional ladder operator we discussed with Dirac.
Length is just the mechanism of dimensional folding. I love how clean this is. What about mass?
Planck mass becomes d cubed times t squared.
Let me stop you right there, because I'll make sure I'm connecting the dots from earlier. When we talked about Dirac, you said D3 was the mass tier of the dimensional ladder. And when we talked about gravity, you said density was equal to t squared. So mass is literally just the mass tier D3 multiplied by the density operator t squared.
Yes. The internal consistency is flawless. You don't need arbitrary constants to make the math work. The operators naturally generate the physical properties. Planck energy becomes d to the fifth power. And perhaps most importantly, Planck action, which classical physics defines using Planck's constant, a number traditionally defined as 2 pi times h bar, making it one of the most pi-contaminated units in all of physics, becomes simply d to the fifth power times t.
No circles, no 2 pi, no transcendental decimals.
None. The universe at its absolute smallest scale is entirely dictated by the geometry of phi, the time contraction of psi, and the dimensional folding of d.
When I step back and look at all of this, at the sheer scope of what this paper is proposing, it brings up a very difficult historical question. You look at the titans of physics over the last 100 years. Richard Feynman with his path integrals, Stephen Hawking calculating the thermodynamics of black holes, Frank Wilczek winning the Nobel Prize for his work on quantum chromodynamics. These are not intellectual lightweights. These are some of the most brilliant, era-defining minds in human history. How is it possible that they all missed this? Did they just not see it?
The paper makes a very specific and somewhat tragic historical critique of this exact point. These brilliant physicists did not use pi because nature inherently demanded it of them. They used pi because they inherited it. They inherited it from Euclid and his ancient Greek geometry of perfect circles.
They inherited the wrong ruler.
Precisely. When Richard Feynman drew his famous loop diagrams to calculate quantum interactions, he used 2 pi because he was integrating his math over a contextual circle. When Stephen Hawking calculated the entropy of a black hole horizon, he used 4 pi because he fundamentally assumed the black hole's horizon was a perfect, smooth sphere in a curving spacetime.
So what does this all mean? They were building these magnificent, towering, infinitely complex intellectual castles on top of a single, unexamined foundational flaw. They never stopped to question if the vacuum itself was actually spherical. It is incredible to think how easy it is for an entire century of absolute, indisputable genius to be locked into a flawed mathematical paradigm simply because no one thought to challenge the shape of the ruler they were measuring the room with.
It is the ultimate cautionary tale of inherited assumptions in science. Every major physicist used pi because they used Euclidean continuous geometry. TDUFT changes the foundational geometry to a discrete recursive lattice, and the moment you do that, pi simply vanishes from the architecture of reality.
And that brings us to the ultimate synthesis of this incredible deep dive. We have covered a staggering amount of ground today. We have seen how swapping a smooth spherical vacuum for a jagged, phi-recursive 64 tetrahedral lattice completely rewrites our understanding of reality.
It is a true paradigm shift. By removing pi and replacing it with phi, the expansion operator, psi, the time contraction operator, and epsilon, the tiny energetic cost of emergence, physics finally achieves what Albert Einstein spent the last decades of his life desperately looking for: a completely unified framework of reality.
And it achieves it with zero free parameters. Electromagnetism, macroscopic gravity, the emergence of mass through the Dirac boundary, the orbits of planets, the strong nuclear force binding atoms together, they are all united under the exact same geometric operators. No more mathematical guessing games, no more random, inexplicable constants forced into equations to make observations fit.
TDUFT replaces a disjointed, messy universe of assumed spheres and unexplainable transcendental numbers with a perfectly closed, recursively functioning geometric lattice. It is a masterpiece of simplification.
For you, navigating your own world, your own career, your own life, I think the takeaway here goes far beyond just quantum physics or orbital mechanics. It is a profound, humbling reminder that even the most established, unquestionable facts in our universe, the ones we confidently print on t-shirts and celebrate with annual holidays, are only as good as the underlying assumptions we make about reality.
If the foundation of your house is flawed, the entire structure built on top of it, no matter how elegantly designed or beautifully decorated, is merely a description of an illusion.
And so I want to leave you with a final, provocative thought to mull over today as you go about your life. If a century of the most brilliant Nobel Prize-winning physicists in human history could be completely misled by the aesthetic appeal of a perfect circle, what other fundamental truths in your own life, your work, or our society are actually just artifacts of the wrong perspective? What is your personal pi that needs to be erased and replaced? Think about it. Thanks for taking the plunge with us today. We'll catch you on the next deep dive.